Welcome back to Heavy Wireless, a podcast that's part of the Packet Pushers Podcast Network. Today we're talking about the WLAN Pi. The WLAN Pi is a great community project that's been going on for a couple of years now. And at WPC a couple of weeks ago, we had a nice update and a deep dive on WLAN Pi. And I thought it'd be a great thing to bring to the Heavy Wireless podcast listeners and have you also listen in and hear what's going on with the WLAN Pi project. To start us off, I have Jiri Olla, and Jiri has been around in the project since the beginning. How are you doing, Jiri?
Hey, Keith, doing well. Yeah.
Well, tell us the history. How did this thing get started?
Yeah. So as the founder of the WLAN Pi project, I can go back to the beginning here. It started back in 2016, actually coming out of the Wireless LAN Professionals Conference, WLPC. And just through that conference and working with other folks there, saw there was a need for this portable type device that, engineers could use to be a Swiss Army knife of different tools, right? For anything from an iPerf server to some type of a console into equipment device. But yeah, a lot of different use cases that we found and have developed over the years with all the contributions from the community.
Well, remembering back to Budapest conference, we had a precursor to this, the Odroid device. It was a headless little single board computer. And we had, a couple hundred people trying to build a computer without any screens. It's improved quite a bit since then. So what kind of improvements have started? I mean, it's still a single board computer, right?
Yes. So pretty crazy to think that, after that initial kind of beta versions, we'll say, of like the WLAN Pi kind of hardware and trying to figure out the right kind of hardware platform, that it ever got some legs and has gotten as far as it has, because the first few years were pretty rough, making things work from a hardware standpoint as well as a software standpoint. But some dedicated folks in the developer side of things were able to contribute and continue to evolve the hardware to where it is today. We started out on the Odroid platform. I think it was the Odroid C2. It was kind of the first single board computer that we found that had a gigabit Ethernet port that could actually push a full gig of throughput on that Ethernet port. So that was how we ended up landing on that one as our first kind of platform.
Well, one of the first things that I used it for, and I'm sure you used it for, because you showed me how, was as an endpoint to be a speed check across the air. So you want to talk to an AP, you want to send a data, but you also you have to have the AP plugged into some piece of hardware to hit. So you could test the Wi-Fi only. We could always do speed tests, but then you're going back to some server someplace else. So the WLAN Pi, the reason you mentioned it needed a gig port is so that we could at least have that piece not be the bottleneck.
Yeah, and that was the challenge, is we needed a way to do like what I like to call a closed loop test. So that way we're just testing the Wi-Fi, right? With the at least as close to that Wi-Fi Fi as possible. So we're not going out and testing the ISP and everything else that goes in between your speed test, websites, that we could do just a closed loop network test and be able to isolate, is this problem locally or is it, more globally?
Well, that was the start. First thing I used it for. Well, what other? You said Swiss Army knife. So obviously there's more than just the speed test blade.
Yeah, on the Wi-Fi side of things, it's evolved quite a bit, where we support a ton of different drivers and chipsets as it relates to Wi-Fi cards, whether it's a USB Wi-Fi adapter or like in the latest generation hardware, we even support, these M.2 Wi-Fi chips, just like you'd have in like a laptop. So we support a wide variety in the native code in the WLAN Pi OS operating system. We support a bunch of different chipsets out of the box. So it's kind of just this plug and play. You can plug in different adapters, supports monitor mode on many of those chipsets. So you can use that to do packet captures, use those as an access point. So if you need to generate signal as kind of like a signal generator, if you will, lots of use cases for wireless engineers for multiple things in that regard. But then also even as a Wi-Fi client and some really interesting stuff now with needing to do things like Wi-Fi 7 testing and needing Wi-Fi 7 clients to be able to do different testing of different code. This is very versatile for things like that.
Give us, Nick, how about if you do a quick introduction of yourself and tell us, just to give us a rundown of what the current status is, what kind of things do you use a WLAN Pi for?
Yeah, thanks, Keith. I'm Nick Turner, and I've been involved with the WLAN Pi project from just towards the end of the Neo 2 era. So Jerry mentioned that the first one was the Odroid, and I think the one that came after that was the Neo 2 platform. And then due to due to the Neo 2 no longer being available, then we pivoted over to Raspberry Pi, with the theory being that the supply chain would be able to cope with.
You missed the little cycle that you didn't mention, the whole WLAN Pi Pro cycle.
No. I mean, the WLAN Pi Pro was part of the switch to Raspberry Pi,
True,
right? Yeah,
yeah.
with the just the switch from the Armbian system over to Raspberry Pi. But the yeah, so right now, I mean, we should talk about the Pro. We should talk about the Pro, as that was kind of the debut uh, for us of trying to roll out hardware at scale. But the the switch over to Raspberry Pi overall has gone, I think, really well. And like Jerry said, the the ability for a Raspberry Pi brain, so a CM4, to be placed on a carrier board that then offers up a M.2 slot, giving us much more access to Wi-Fi modules, has been, in my opinion, one of the keys to the WLAN Pi's one of the keys to the WLAN Pi's success. I guess the low cost, build it yourself DIY nature is key to the project as well. But for example, with Wi-Fi 6E, I like the story that the WLAN Pi project was one of the first groups to market with a Wi-Fi 6E tool. I'm not sure how true that statement really is, but nevertheless, with a WLAN Pi, I had a laptop that was not Wi-Fi 6E, but with a WLAN Pi in my pocket, sorry, with a WLAN Pi in my pocket, be that a Pro, an M4, or an R4. We'll talk about those model names in a minute. But I could do scanning. I could scan Wi-Fi 6E networks, even though my laptop was not 6 gigahertz capable.
Let me back up just a second. A lot
Mm.
of people know what Raspberry Pis are, and they think of Raspberry Pi, threes or fours. You mentioned two new words, a CM4 and a carrier board. So compared to a
Yeah.
Raspberry Pi that a lot of us have played with for little projects, how do those two things fit in?
Yeah, I think the easiest way to look at this or think of this is that a Raspberry Pi 4 is a single board computer with all of the I/O ports, all of the in-out ports predefined. The Raspberry Pi 4 ships with two USB 2, two USB 3, an Ethernet port, a couple of HDMI, and a USB-C port for power. And that's it. You can't get a variant of the Raspberry Pi 4 with different ports. To address that need, and specifically the industrial use cases, the Raspberry Pi Foundation came out with the concept of a compute module, so CM3 or CM4. And that is a smaller board with just the brain of a Raspberry Pi. And there is no in and out ports defined. You must stick that compute module onto a carrier board, and the carrier board then breaks out the various ports that you might want, which gives the Raspberry Pi product family far more flexibility now, because Raspberry Pi don't have to make endless variations of a Raspberry Pi. They can just make, here is the brain, and you stick it onto whatever board you want. Raspberry Pi Foundation do make a carrier board specifically for development, but there is a wealth of small, large, varied carrier boards that introduce all sorts of different ports. So you might have a board with multiple Ethernet ports, or a board with 15 USB ports. So provided you have the electrical design skills, you could create a carrier board with endless variation.
Thank you for the update.
Maybe now would be a good time to bring Jiri into the conversation about about some of the carrier boards that have been played with.
Yes, absolutely. So I'm Jiri. Thanks for having me. And I mean, quite recently we've been developing a new prototype of the M4. So if you're familiar with the WLAN Pi M4, the modular one with M2 adapter, what we've done recently is we have introduced Wi-Fi 7 support, so you can now use a M2 Wi-Fi 7 adapter inside the M4 natively. Plus, we're bringing a few new features. So some of you might have seen this, but if you have not, we're working on OTG, which is basically a IP connectivity between an iPad or laptop and the Pi. So you don't need Ethernet, you don't need Bluetooth. You can basically use the USB connection between the Pi and the and your device. So that's something we are working on, as well as Wi-Fi 7, which, as Nick mentioned, you might have a laptop which doesn't do Wi-Fi 6E, doesn't do 6 gigahertz. You probably have a laptop which doesn't do Wi-Fi 7. So with a Pi like this, which has 6E or Wi-Fi 7 support, you can basically add that capability, if you will, to your laptop, use the Pi as a remote sensor, and yeah, basically do Wi-Fi 7 scans, Wi-Fi 6E scans.
Well, hello, listener. You know, getting into the cloud is easy. It's what happens once you're there where things get interesting. On the Day 2 Cloud podcast, hosts Ned Bellavance, that's me, and Kyler Middleton explore the nitty-gritty of cloud operations, from tooling and automation, to resilience and security, to visibility and cost management, and so much more. We talk with technical leaders, practitioners, trainers, and consultants on all aspects of cloud operations to equip you, yes you, with the information you need to address technical and business challenges in the cloud. So whether you're public, private, hybrid, or multi-cloud, let Day 2 Cloud be your guide. Listen at packetpushers.net or wherever you get your podcasts.
I think it's time to go back to what Nick had alluded to. WLAN Pi Pro, M4, R4, those are terms, and for people who know what they mean, it actually represents something in physical space. Maybe for our audio-only audience, you can describe the difference between those three.
Yeah, okay, I'll jump. I'll take this one. So a Raspberry Pi 4 has the ports that I described, and we turned the Raspberry Pi 4 into the WLAN Pi R4, which you can think of those two things as separate, if you like, but really a WLAN Pi R4 is just a Raspberry Pi 4 with a 3D printed fascia stuck on it. The Raspberry Pi board sits inside a aluminium case, and there's a screen. And we called that unit, or we refer to that unit as the R4 because it is a Raspberry Pi it's a vanilla plain Raspberry Pi at its core. And then we needed to come up with a way of differentiating the models of WLAN Pi that we started to design and encourage other people to build or buy. And then this is slightly out of sequence, but we have the M4, which is different than the R4 because that's the one that is a compute module sat on a carrier board. And the company that manufactures the PCBs that we use for the M4 is called MCU Zone. And we just we latched onto that name and it stuck. So we have the WLAN Pi M4. The M4 is also the modular one, and the WLAN Pi with an M.2 slot. So, pick whichever representation of the letter M you like. The M4 is the unit that has the M.2 slot in it, and that was the unit that brought Wi-Fi 6E to the game early.
So there's just to clarify, there's two kind of hardware tracks right now that are being offered through the WLAN Pi project. Is either like a build it yourself route where you go like the Raspberry Pi side and then get the parts and pieces like Nick is talking about here with the fascia kit, and you roll your own WLAN Pi, if you will. The other side of it is the M4, which is the already kind of pre-built offering where we assemble it and everything. Nick, for the most part, assembles it, and then has those available. We have some exciting stuff on that side of it, on the M4 side of things. So really kind of right now, as far as the project goes, most of our effort on the development front is towards the M4 because that has some customizations from the hardware that we've done ourselves. So that's where most of our kind of development efforts are being focused on. And yeah, there's some exciting stuff, I think, going on the M4 that we're kind of ready to start to talk about and kind of tease a little bit here of where that's going. We're getting a lot of questions about that. So I figured this was a good platform to kind of, kind of soft announce some of that. So,
well, I like that. I just wanted to bring up that all WLAN Pis run the same code. So if you have an R4 and you rolled your own parts, or you have an M4 that you bought, or if you were one of the lucky ones who had a WLAN Pi Pro, it was a limited run, all three of those hardware platforms work with the exact same firmware. And the firmware is constantly being updated. So, and if you're one of those old folks who've been around for a while and have Neo 2s, there is a WLAN Pi firmware for the Neo 2 platform. Obviously, it doesn't have all the same features because Neo 2s are a little older, but you can run a lot of the same things on top of it.
The WLAN Pi Pro, just so anybody who doesn't know what that is understands, the WLAN Pi Pro was a compute module on a carrier board, but the carrier board was something that we designed with a third-party company doing the electrical work, but the WLAN Pi project defined the requirements for that carrier board. And we kind of ran wild with our wish list, and we put as many things as we could into that board. And it was not a failure, but it was not viable to continue producing them, is the short story of the WLAN Pi Pro. The M4 is the distillation of the Pro. It is not as feature rich, but it is viable as a unit that we can keep on focusing our efforts on, whereas the Pro would have required enormous amounts of investment and kind of turning it into a full-blown product, which the project did not feel like we wanted to go down that route at that time.
Here we are today. We have R4s that you can build your own, an M4 that you can buy, and let's return back to Jiri talking about what's the future look like, or what kind of new things do you see coming to the M4 platform in the future, and what are you going to call it?
Good question, Keith. So I think if we started the M4, the current gen, if you have the modular with PoE M2 slot where you can basically replace the Wi-Fi module and upgrade from Wi-Fi 6 to Wi-Fi 6E to Wi-Fi 7. Recently, we have launched a little adapter. Essentially, the M4 has an M2 slot with a specific format. There's basically a little notch on the adapter and a little key on the slot. So what we did was to introduce Wi-Fi 7 support. We basically developed a little adapter. So inside your M4, you can insert this adapter, and inside this adapter, there's the Wi-Fi 7 Intel BE200 Wi-Fi 7 Wi-Fi adapter. So that way you can basically upgrade a standard M4 hardware to Wi-Fi 7 capable M4. And we're working on something we call M4 Plus at the minute. I guess we might change the name, but at this point in time, we call it the M4 Plus, which essentially builds on the M4 capability. So it still has screen, built-in PoE, so there's no external power supply needed. And it natively takes a Wi-Fi 7 adapter. So it basically has the right key out of the box. It ships with Wi-Fi, or it will probably ship with Wi-Fi 7 adapter in there. And perhaps when Wi-Fi 8 becomes a thing at some point, we hope that the slot might be ready for those kind of future adapters. So yeah, recently we've been quite heavily testing the prototypes. I think at the minute we are at prototype number 3, if I'm counting correctly. And we've actually done some Wi-Fi 7 tests. So I can actually tell you that on Linux, I've got better results than on Windows. Essentially, on Windows 11 at the minute at this point in time, this Intel adapter only does 6E on Windows, but on Linux, it does Wi-Fi 7, which means you can use a super wide 320 megahertz wide channel if you choose to for testing, as we did. Obviously, you will not deploy this in an enterprise. I think even in the consumer space, it would be quite quite challenging. But essentially, with the M4 Plus, with the Wi-Fi 7 adapter in there, you can get two speeds around the actual TCP throughput of 2.2 gigs or so in each direction. And from what I've tested, it looks like that it's actually the M4 platform, the system on a chip, the actual CPU, which basically is not able to handle that much traffic.
You mentioned that much traffic, but 2.2 is pretty decent traffic.
It is, yeah. I mean, that's the actual useful TCP throughput. Obviously, that there's overheads and there's all of that traffic that the CPU needs to process.
Yeah, I think what I'm most excited about with the M4 Plus is that it brings feature parity to the RPI 4. So one of the things that we have right now is we have the RPI 4 or R4 and then the M4. And right now there's some disparity between the two. There's some features that the R4 have that the M4 doesn't have, like the OTG, where you can have just a single cable, and you can power and talk to the device over that single cable. You can do that on an R4 today. You can't do that on an M4. And the M4 Plus is going to bring features like that. So they'll have that feature parity, but then in addition, you'll have things like PoE natively built into it where you can power it over PoE. Obviously, the Wi-Fi 7 piece natively built into it. So I'm excited about that aspect of the M4 Plus is that now between these two offerings, you'll have a single offering that can do everything the other one can do, plus some extra things. And that's where there's kind of a gap right now in the hardware is there's two different pieces of hardware, but it's not like one is better than the other. It's just different use cases, different features kind of between those.
It's always been a decision. You got to choose, do you want PoE or do you want OTG? And that, if you know what those things are, you can make that decision. But if you're unsure about those terms, and then you end up having a whole conversation about it. So yeah, the biggest problem has been this divide between the M4 and the R4, and we're hoping that the M4 Plus gets rid of that. And now it's a choice of, do you want to build it yourself, or do you want to get this unit that works out of the box? And their features are pretty similar.
Well, we've talked a lot about hardware and different platforms and all those things. Let's talk about the software. What can you make this do? All three of you have taught at some time or another the WLAN Pi deep dive at WLPCs, and you have a series of labs you go through. For our audience now, Jiri, can you just tell us what can you make this thing do? How is it used? And I don't care if it's Jiri or Jerry.
So I'll go first then, Keith. I think my personal favorite one at the minute, and I actually used that when I use one Pi to test the latest Pi, is the remote sensor capability. So I can basically take a Pi, use its Wi-Fi 7 radio or 6E radio for scanning or PCAPs, packet captures. And at the same time, I can connect a USB spectrum analyzer into the same Pi, and I can connect to it remotely from the laptop and basically use that as my sensor to monitor the actual RF, plus do Wi-Fi scans or take a PCAP at the same time. So that's what I like.
It's small, the size of a Raspberry Pi, and you can leave it behind somewhere. What do you need connectivity-wise in order to access that remote sensor?
Connectivity-wise, it's basically just a plain IP connectivity. So it can be just on the same LAN, or it can be accessible via VPN, and there are actually multiple options how to connect to it via VPN. But essentially, plain IP connectivity, typically SSH connection to the Pi. And over that SSH session, we can then run the commands or get the output.
Jerry?
Well, I was going to just even back up for a second on the software side of things and just kind of highlight the community aspect of this. So you talk about like what can you do with the WLAN Pi OS, right? And just to highlight that this is an open source platform and it's all community driven. So you got a few of us on here kind of talking about some updates and stuff on the project, but there's many more folks behind the scene that obviously have gotten the project and the suite of tools to where it is today. But yeah, I think just some of the exciting stuff on there of some of the use cases is, having the Swiss Army knife of, being able to do speed tests, being able to do Wi-Fi scanning, be able to use it for network troubleshooting. I use it often for just a quick network tester tool, right? Where I just need to see, okay, why in my lab am I not getting out to the internet when I plug a device into this port, or why is it not getting an IP address? The WLAN Pi, that is always kind of my go-to of, I've got one nearby and I plug it in and I can see what VLAN I'm getting, what IP address I'm getting. I can see all the LDP info of what's at the other end of that switch or that port that I'm plugging into. So I think that, there's a lot of nice use cases for wireless engineers or network engineers in general.
And Nick?
And I think what can you do with the WLAN Pi? Out of the box, you flash an SD card with the WLAN Pi OS image, which is freely available. Anybody can download the image, input it into a Raspberry Pi, and out of the box, it has a suite of tools. But at the end of the day, it is a Debian Linux. It's a fork of Raspberry Pi OS, which is Debian Linux. So the real answer to the question of what can it do, it can do anything that a Linux computer can do. You can install any other Debian package onto this. I often describe the WLAN Pi as a platform onto which you can do other things. But that's where I think the versatility of this project shines, because for some people, this is a defined tool. You take it out of your bag and it does the things that the WLAN Pi development team have made. But other people take it and build their own projects on top of it, and it becomes something else.
And from a user perspective, for me personally, the beauty of the Pi is that I can just start using it. I don't need to build a custom kernel to make this Wi-Fi 6E adapter work. I don't need drivers. Basically, we kind of package it, pre-install it, test it. So you basically flash the SD card and you can actually start using the features we have kind of pre-built and developed. But at the same time, we have people who came back to us and they said, look, I built this Grafana solution. If you want to, I can help you. And you can include it in your image. So when Brian came to us, we said, yes, absolutely, we would love to do that. So that's just one example when kind of people are excited about what they do and they're willing to share and contribute it back. So yeah, if you have a skill and whatever it is, and you want to share, you want to join the community, please do let us know.
Well, I appreciate all of your time today talking about WLAN Pi. I think it has legs. It started out as a simple project. Now it has a whole community behind it. Like you said, if you want to just take any Raspberry Pi you have, flash the image, you can play with it as well. If you're afraid of Linux, you can just boot it and hit its web page and do a lot of the features. The tools have been put just into a web browser. If someone wanted to delve in, and these are the questions I have that would be adding the show notes. Where would they go to get involved in the project? Where would they go to learn more about WLAN Pi? And where would they go to buy one?
the first place to go is WLANPi.com. That's our homepage. As with many projects, it's in an endless state of redesign, but I think it's in a pretty good state now. But through the website, you can get a link to download the image, which is hosted on GitHub. You can also contact the team through the contact us page on the website. I think a little chat window will pop up, and you can try and get in contact with us that way.
You can subscribe to the mailing list, and we definitely will not spam you, because I think we've sent out maybe one or two mail blasts.
Mail blasts today is one. We will at some point send out an update on the project, but yeah. So where to go to get in touch with where to go to find out more about the project? WLANPi.com. The other bit of public data that we should share is, if you're scared or intimidated by a WLAN Pi and you don't know where to start, we have published cookbooks, and I'm doing air quotes. But when we say cookbook, what we really mean is publicly accessible lab guides. And the story here is, each year at the WLPC conference, we host a WLAN Pi deep dive, during which everybody who attends the deep dive gets a WLAN Pi, and we run through a series of labs. And then some months after WLPC, we eventually take those labs and put them into the cookbook. And so the cookbook is a user guide or lab guide, but it is essentially a series of instructions that walk you through performing various tasks that we think people would want to do with a WLAN Pi.
Wonderful. Thank you again for your time. WLANPi.com. We'll keep other links in the show notes. This has been another episode of Heavy Wireless, part of the Packet Pushers Podcast Network, and we're glad you joined us today. Look forward to talking with you in the future. Thank you.